Hello, this is the third short video on how t-tests work, and there's also the two short videos showing this sampling distribution, which I hope you watched in between parts 2 and this one. But let's just recap what the sampling distribution should show you. It's shown that when you have a parent population like this and you take samples of size 5 and 25, what you find that the distribution of those sample means, size 5 or size 25, has a much smaller spread than the distribution of individual values, and the spread reduces down even more for the bigger sample size. We also found that this still works when the distribution of individual values is not at all normal, even if it's extremely messy. The sampling distribution of the mean still has a normal shape and with a reduced spread. Now, this brings us on to two conclusions. Well, one is called the central limit theorem. You can prove with advanced maths, which we will not be tested on or expected to know, but you can prove with advanced maths that as the sample size n grows larger, then for any distribution of the population, the original population of individuals, the sampling distribution of the mean, which means that blue distribution of the means of size 5 or means of size 25, that distribution of sample means has got a standard deviation itself, which is the original standard deviation, sigma, that's the individual standard deviation, divided by the square root of n, the sample size. So as the sample size gets bigger and bigger, you divide by this square root, and that reduces the standard deviation. In other words, that's reducing the spread of those sample means. So if you had a sample size 16, square root of 16 is 4, so the standard deviation would be 4 times smaller. If you look back at the demonstration, you should be able to check for yourself that that worked. Not only does that happen, but the shape of the distribution gets closer and closer to a normal distribution. Now we can use this central limit theorem, or the CLT, to get what we really need, which is some z-scores for samples. So, if you sample n individuals, then the sample mean z-score is given by this formula, and even though you don't have to know all this maths, we won't test you all the maths, you will need this formula. You might have to do some calculations with this in your coursework, or more importantly in the test, so you need to remember this. Now what we've got here is, it's similar to the z-score formula, except here, instead of the individual mean, you've got instead of the individual value, you've got these sample means. That's the mean of your sample, and you're seeing how far away is that from the population mean. And then instead of steps of standard deviation, you're doing steps of standard deviation of the sample mean. So this is the standard deviation of those sample means, all the possible sample means you could have, the blue ones. And it's the individual sample mean divided by the square root of n. This altogether, the standard deviation of the sample means, that's known as a standard error. So this formula can let you work out the z-score for any sample, and we'll have plenty of examples of this in the workshop.